So lesson 19.3 is we're continuing about our discussion of fossil fuels and how we are now going even further than we had to before to get to new sources of fossil fuels because we have gotten out all the easy ones that are close to the surface and close to the shore. So now we have to dig further for sources of fossil fuels. So we have, so we're in a time where a lot of people think that we should be transitioning to clean and renewable energy sources, which we'll talk about in the next few chapters. But instead, a lot of us are, our society appears to be doubling down on its bet on fossil fuels, meaning that we're putting in even more money because now there's a greater reward since they are fewer and harder to come by. So some ways that we're going further to get fossil fuels is by mountaintop mining for coal. This is literally removing the top of a mountain by dynamite, by exploding it. And then you can get to the fuel that's buried inside the mountain. Secondary extraction from existing wells. Hydraulic fracturing for oil and gas. This is called fracking. We're going to talk about that. Offshore drilling in deeper waters, so going even further out offshore and exploiting new unconventional fossil fuel sources. These all increase fuel production but reduce the ROI of our fuels. So that means that we don't get as much money. They're not as, it's not as good of an investment in them anymore because it costs more to get them. They intensify pollution and worsen climate change. So not very good. So the first one is mountaintop mining removal, and this is when it removes literally the entire mountaintop to access the coal seams running through them, and it produces a huge amount of rock and soil erosion, as you might imagine, because we're getting rid of the top of a mountain, and then all of that needs someplace to go, and it's just not good. The massive scale on which you can get coal out of there by doing this makes it economically efficient because it's probably not very economically efficient to blow off the top of a mountain, but if you can get to huge coal reserves, then it would be. But it can cause staggering volumes of rock and soil to slide down slope because you blew it off the top of a mountain, degrading or destroying entire hillsides, polluting or burying streams, and disrupting life for people living nearby. All of things which I'm sure you could imagine if we just blew off the top of a mountain. Then we have what's called secondary extraction. And this is when at a typical oil or gas well, as much as 2/3 of a deposit may remain in the ground after primary extraction because you kind of reach the point where it gets too expensive to keep going. But if we're running out, we will pay that cost and keep going. So basically then what happens is solvents, water, or steam are injected into the well to force the remaining oil or gas out by pressure. And it's a much more expensive process than primary extraction, so we can't get these out by primary extraction, so we have to use this what's called secondary extraction. And it only happens when market prices of oil and gas are high enough to make the process profitable. So normally it's so expensive that people wouldn't do it, but if for whatever reason the fossil fuel prices, the amount that people are being charged at that time, which varies, that's why gas prices go up and down, that's what we're talking about. If it's really high, then it would be worth it because you could make the money back. Then we have directional drilling, which is when it's a technology that allows drillers to bore down vertically and then curve to drill horizontally. So instead of just needing to drill straight down into the ground, they can drill down and then get a radius around it. So that way they can get to a larger pool of water with oil with one drill. This allows drillers to reach a large radius around each drill pad without constructing additional drill pads. This increases efficiency and profits because you can get to more oil from the same spot. Then we have what's called hydraulic fracturing, also known as fracking, if you've ever heard of this. So basically what happens is that we pump untreated or chemically treated water under high pressure into layers of rock to crack them, and then we use small glass beads or sand injected down in there to hold the cracks open as we withdraw the oil. So the gas or oil will move upward with pressure and pumping through the newly created systems of fractures. So hydraulic fracking, because the water is used to create the fractures. This ignited a boom in oil and gas extraction in the U.S. Our new flow of oil from fracking reduced U.S. dependence on foreign imports, and by 2016 led to a glut on the world market that brought down oil prices to less than 1/4 of their 2008 high. 2008 gas was about $5 a gallon, and now it's right around $3 in other parts of the country, even cheaper. So fracking allowed us to gain access to a lot more oil, which brought down our oil prices by a lot. And it's become a major debate in the States, especially above the Marcellus Shale deposit, as it created many new jobs, but drew down water resources and in some cases polluted water. And I don't know if you guys there's a few movies about this, one called The Promised Land, which has Matt Damon in it, about this and how, because a lot of then suddenly these people's homes have this huge fracking device in it, and so it's causing pollution and all that, so it's very controversial. Then additionally, we are drilling farther offshore, so that means that we're putting our oil rigs further and further off of the shore to get to new oil sources. So roughly 35% of the oil and 10% of the natural gas extracted in the US today come from offshore sites such as the Gulf of Mexico and coastal California. And deepwater drilling technology has outpaced our ability to deal with accidents, as shown by the Deepwater Horizon oil spill in 2010. What happened in this case was faulty equipment allowed so faulty equipment allowed a natural gas deposit that was by an oil deposit to shoot up a well shaft. So the well is how we get down to the oil deposit, and there was natural gas right there as well, because we know that natural gas is usually found above an oil deposit. And the gas shot up the well and caught on fire at the top of the well, killing 11 workers and leading to the largest accidental oil spill in history. I don't know if you guys remember this. It was in 2010. It took 86 days for BP to be able to plug the hole. Plug the oil spill. 3 months. Oil was just leaking and leaking and leaking into the Gulf of Mexico. So not great at all. So so because of the Deepwater Horizon, it forced a temporary hold on new drilling in 2011 until new rules and regulations could be designed to make sure that this wouldn't happen again. Now there's also another new source for fossil fuels, since the Arctic is now no longer as covered in ice. It's opened up many areas of the Arctic to offshore drilling. But offshore drilling in the Arctic poses severe pollution and safety risks, because frigid temperatures, ice flows, winds, waves, and brutal storms make conditions challenging and accidents likely. And then if an oil spill were to occur, icebergs, packed ice, storms, cold, and wintertime darkness would hamper response efforts, and freezing water would slow the natural breakdown of oil. So basically, it's more likely to have an accident here if we're drilling, and if there is an accident here, it's much, much harder to clean up. So especially if it happens in the winter, like wintertime darkness in the Arctic, the sun, some days there's no sunlight. Some days the sun doesn't ever come above the horizon, depending on where you are. So that makes it much harder to clean up after a huge spill. And there's one company, the Royal Dutch Shell, like Shell Oil, has attempted to drill in the Arctic, but a series of accidents and protests led them to withdraw from the drilling as of 2015. We are exploiting new fossil fuel sources. There are an estimated 3 trillion barrels of oil shale to be extracted, much of it in the U.S. But the ROI of oil shale is low, ranging from 4 to 1 to 1.1 to 1, so not a very big return on investment at all. But these sources of unconventional, so if you remember, that's oil sands, oil shale, and methane hydrate, they in theory are abundant enough and could together theoretically hold our civilization off for centuries, using them in place of the 3 conventional fossil fuels. There's enough of them. But the net energy values and ROI are very low, and they exert severe mental impacts on land and water. So it's not a good option. And then methane hydrate is one of them. It's also abundant, but so far only Japan has attempted to extract it due to concerns about accidental releases of methanes, which would make things even worse, given that methane is a very powerful greenhouse gas.